Okay, I'm going to give a very quick talk on Exaworks and what's been going on there, and remind folks a little bit of what we're doing. Hopefully the slides are up. By the way, my compliments, Kyle, on working the word fortnight into your presentation. I highly value that word. So
about bi-weekly that I have a problem with.
All right, so yeah, we're part of the ECP, the Exoskeleton Computing Project. This is just a reminder slide. I think. Sorry. We are basically preparing to run our stuff on Frontier and El Capitan in the context of ECP, and we're working on testing there and working with teams that are going to be planning, and they're working with teams that are planning on running there. So this is becoming a reality very rapidly. The hardware is already, early access is already there, and the new hardware is coming if it hasn't already reached some sites, at least in its nascent mode. So we're part of this project in the software technology area, working on a sustainable, essentially we're basically trying to build a sustainable workflow ecosystem. So we're not building a workflow system itself, we're basically building a software development kit. We're trying to democratize access to high quality scalable workflow tools. On the right, you can see that we have an aspiration to have a full deployment cycle. We're building that out. I'll talk a little bit about that. Continuous integration, continuous deployment, broadly tested across multiple DOE and other sites. And Parcel is part of our initial toolkit. We also have Radical Cyber Tools, SwiftT, Flux, and a few other components, I think Balsam as well. Although currently our focus in testing and production is really these four: Flux, Radical, Parcel, and SwiftT. We're looking at basically putting forward community policies for inclusion of future workflow systems, and we're hoping to start that process this coming year once our testing infrastructure is in production, and we're basically focused on scalable systems. So just a quick picture of a little bit of kind of the software stack we're aiming for, and the idea that we picked systems that were both scalable but also provided nice software architectures for us to really leverage, to look at ways we can begin to work towards common APIs or common capabilities for the workflow community, so that each team's not writing its own layers underneath, but we can start to share some of that load and potentially arrive at some community standards. So that's one part of our project, and I'm going very fast. We also engage the community. As Kyle mentioned, we are currently in the planning stages for the next workflow summit, essentially a community gathering of workflow technologists, and I think potentially user community and facilities folks as well. So we've hosted a lot of these. We've got several reports that you can find on our website, but we're trying to build consensus and establish sort of a community for workflow standardization that we hope to propagate into the future after the ECP ends, which is at the end of this next fiscal year. Our roadmap, we are working very hard right now on SciJ release. I'll talk a bit about SciJ. That's our portable submission interface for jobs. And then we're also due for an SDK release, a version 1.0, which will mean essentially assembling the tools together with good documentation and tutorial materials that allow people to try them out easily, and allow teams to kind of make a choice and have access to some high quality, well-tested software on their sites. So the goal here, I think, with Exaworks is to move beyond the model where each workflow team is supporting a set of users with sort of pipelines of funding. We're looking at a way to build a sustainable software community for workflows where various teams can come together and kind of share some of these hard to do things, like the continuous integration type processes, where it's very hard for a single team to do that across, say, every DOE site on all the dozens and dozens of clusters. But maybe if we can create a community around this and engage the facilities, we can make this possible, so that users can have more confidence in the workflow tools, and that the software can have a sustainability story beyond, particular funding streams. So we are working towards production quality continuous integration. We have developed a GitLab CI infrastructure and a GitHub infrastructure. We are working hard on CI at Livermore, Oak Ridge, and Argonne. I think we have it running at most of those places. Livermore was running. We're currently getting it back up and running because it lapsed because of some change in the spec install at our site, we think. we're testing SciJ, this portable submission interface, on a variety of machines. And this is a picture of a prototype dashboard that we're building. So essentially our goal is that this will be the dashboard that a person adopting something like SciJ would be able to look at. So there would be a common test suite. They would be able to see, different sites of interest to them. And then we're hoping to have a set of examples from our documentation to appear on the dashboard so that people can see, oh, I have a simple ensemble example. It's running at the site that where I run, and I can go look at that example and try to run it at my site and have confidence in the tool. So one of the things we're trying to do is overcome adoption barriers for workflow technologies in end users in particular. So we have kind of two communities we're trying to target. One are the workflow system developer community, where we're hoping to share the load testing all this stuff, but the other one is those small teams of domain scientists, where they often build their own stuff because the complexity of most workflow systems is too high for them at their particular stage of development. So we're trying to make things easy for them to get into and to have confidence that the software will work. And I can show a little bit of this dashboard if I have time. So SciJ is basically a portability layer. It's a language independent specification with a Python reference implementation. We have implemented several backend schedulers for SciJ, and the goal is to basically create at least with the reference implementation, make it easy for Python code to submit jobs at sites and manage those jobs. And so it kind of looks like this. You get to make a job. You have a Python interface. You have futures that you can submit and kind of monitor. You can cancel jobs and other things. We are working basically right now on just the job submission piece. We have aspirations to also enable cross-site functionality and also be able to pack jobs or to perform the pilot job model within SciJ, so to schedule workloads within it. But currently those are separated. We've integrated it into both Radical, CyberTools, and Parcel. And so the idea is we're going to eat our dog food here. And when SciJ is ready and tested widely and has a 1.0 release, we're going to bring it into the SDK itself as another member. So the idea here is to abstract as much as possible the process of writing those batch scripts or interacting with schedulers. This doesn't solve the problem of the fact that every site has its own policies. So that's a separate issue that we're going to try to attack from a community perspective. So that's my talk, and I was going to just show really quickly, since I'm still sharing, that the SciJ. So this is SciJ testing. This is all live. So these green dots mean it's passing, and we can accordion this stuff. So this is for the developers to see all the different places we're testing and which systems it's running on. And then we have this prototype dashboard that also we're hoping to essentially go live with more data as we build out the testing infrastructure. But this is all real. You can find stuff on our website. Earlier versions of this dashboard are live. We have a testing service backend that we're using with a database to keep track of all these things. The goal is eventually that the community itself, even if we don't have access to a particular system, someone who's using SciJ can test it there and publish their results to this dashboard so that we can help the community sort of understand where it's running and where it's failing. So I'll stop there. Hopefully I'm on time.
Yeah, sounds good. Thank you, Dan. Maybe you can also stop sharing and Claire can start while we see if there's any quick question for you. Questions? Okay, well, I guess, so I was kind of curious, is that test infrastructure going to be useful for anybody beyond the workflows community? Because it seems like it would be helpful for a lot of other purposes as well.
I think how we're doing it will be useful as something to copy. So we're using SPAC to build everything out. We're using E4S. We also have containers. So it's all on GitHub, so you can go look at it. And I think if people want to replicate it or build on it, I think that will be fine. I think there's some idiosyncrasies about how we have to package all our stuff together. It's a little bit different because we're not math libraries. So we are mostly Python with some MPI and compiled code, which makes it a little bit different from the other ECP projects that are packaging stuff up. So I think in that respect, it'll be useful just because it's an example of user space Python stuff that we're trying to propagate and test everywhere.
Okay, great. Thank you very much.